we go. Now we're looking. Our last section, section 2.4, what we are going to do is we are going to graph again. So we talked about graphing for 2 sections, and this time we are going to graph inequalities. Just like when we started off the class, we solved equations, then we solved inequalities, we graphed equations, now we're going to graph inequalities. So the example I'm going to do, and then I've got 3 that you are going to do, and we're going to work together. It looks like this. It's negative 5x plus 2y, and then is going to be greater than 4. Okay, we are going to graph this one together. So this is a lovely section. Again, I told you the first day, my assumption is that most all of you, after this class, you're stepping into college algebra, and we will graph inequalities again there. The only difference is in college algebra, we talk about all sorts of other graphs, not just lines, but the process is exactly the same. Okay, so if you latch onto the process now and you have me for college algebra, I know a lot of you are gonna be like, I never want to see you again. I totally don't blame you. But if you have me for college algebra, I will give you these same 3 steps. Okay, it's the exact same thing. And so step 1 is 85% of the problem, and you already know how to do it. That's the good news. Okay, so step number 1 to graphing an inequality is we are going to graph what's called the boundary equation. The boundary equation is what's going to divide our Cartesian plane up into two halves. Okay, and where we get the boundary equation is we just take this inequality that we have. I don't want to mess with changing the sign and dividing by negatives and all of that mess. So what we're going to do is we're going to say negative 5x plus 2y equals 4. Okay, we're going to just revert back to what we already know how to do. So notice all I did here is I took my inequality, the greater than, and I said, we'll worry about that later. And I changed it to an equal sign because I know how to graph this. So what I'm going to do, well, first let me tell you, you can graph however you want on these. You can graph by plugging in points if you feel like it. You can use the intercept method if you like that. I like the slope and y-intercept, so that's what I'm going to do. Okay, so if you're following along, if you are working ahead of me, don't connect the dots. Okay, when you get there, that'll be step 2. Okay, so here we go. I'm going to find the slope and the y-intercept by first adding 5x, because I've already remembered the same 2 steps, and I'm so happy with those 2 steps. I just use them over and over and over again. And so when I add the 5x, I get 2y is equal to 5x plus 4, or 4 plus 5x if you like that order better. And then I'm going to divide both sides by 2, and I'm just reiterating because I care about you and I don't want you to miss things like this on the test. Don't forget to distribute. So 5 over 2x, and then 4 over 2 becomes 2. Now I know everything I know, or everything I need to know to graph this. I know that the slope of this is 5 over 2. I know that the y-intercept of this is 0, 2. Okay, again, I've done absolutely nothing new. Okay, so if that's not familiar, then please do your homework for section 2.2. So my y-intercept is 0, 2. My slope is 5 over 2. Remind me, since we're reviewing here, the 5 means I'm going to go in what direction? Up. And the 2 means I'm going to go right. Positive y, positive x. So up 5, 1, 2, 3, 4, 5. Right 2, I make a dot. If I go up 5 more, I'm going to go off the grid, and I don't like to do that. So I'm going to go down and left because 2 negatives make a positive. So down 5 and then left 2. And there's my 3 points. I will take my straight edge. I forgot my protractors. I'm sorry. So here's my license, but I have done you the favor of not showing you my license picture so that you will not be repulsed. There you go. Yeah. Oh, what did I tell you a minute ago? Don't connect the dots. And then what did I go and do? Connected the dots. Oh, Perkster, you're terrible. That's okay. We can recover from this. You should teach the class for me, though. If I was a good instructor, I would probably give you bonus points or something. Who knows what will happen. Okay, so let's try again. I'm sorry, everybody. I was just in the zone right there. I was really excited to be graphing. So up 5, 1, 2, 3, 4, 5, over 2, down 5, back 2. I'll let you catch up because I gave you 9 grids. You're not going to need all of them. Just if you connected the dots with a solid line, just go ahead and just scribble through that. So yes, as I was told, here's decision 2. This is the new bit. We have to decide, are we going to connect the dots with a solid line? Clearly not, because I freaked out, or a dotted line. And you make the decision in the following way. Remember back to our second day together, we were graphing stuff on the number line. And there were 2 choices, but we put the number. We either put in a filled-in circle or we put in an open circle. When did we put in a filled-in circle? When we had what? When it was equal, greater than or equal to, or less than or equal to. When did we do an open circle? When it was just greater than or just less than. What's the analogous decision right here? You're going to use a solid line when you have equal. So less than or equal to and greater than or equal to. You're going to use a dotted line when you have just less than or greater than. So thank you for catching this for me before I went too far with the problem. What am I going to use for this problem right here? Yes, I'm going to use a dotted line because the problem I gave you was just greater than 4. So here we go. I'm going to dot this line. So dot, 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 dot. Still not showing you the license picture so that you don't laugh at the perkster. So there we go. There's my dotted line. So that's 2% of the problem. You got to make that decision. And so here's the last 7% of the problem, the new bit of information. The third thing is, since this is an inequality, what we've just done is we've found the boundary. And what that tells me is either all of the points that satisfy the inequality are up here or they're down here. They're on one of the 2 sides. Now, please do not do this. Do not make this assumption. Do not say, oh, it's greater than, I'm going to shade above. That's wrong. Okay, it doesn't have to be. It could be. Okay, but I can change a sign and it can go the other way. You have to test. So what we're going to do here is we're going to pick a test point. The only constraint about the test point is that it is not on the boundary. My favorite test point when I can pick it is 0, 0, because I'm mathematically lazy, because 0 times anything is 0. But you can pick any point you want. We will all come to the same conclusion no matter what point you pick. So I'm going to pick 0, 0 because it's not on the boundary. And I'm going to plug that into my original inequality. So my original inequality was -5 times x. So that's -5 times 0. Plus 2 times y. I'm going to slide this up a little bit just while we're doing this. Plus 2 times y, so 2 times 0. And I want to know, is that greater than 4? Well, here's why I like plugging in 0. -5 times 0 is 0. 2 times 0 is 0. So all I have on the left of this is 0. Is 0 greater than 4? Is that a true statement or is that a false statement? Okay, that's false. And here's what this means to us. I'm going to give you a second to write that because now I'm going to slide it down. I'm going to go back to my, actually, you know what? Happiness. I can just slide the graph down. My test point is where my pen was, or is. I got a false statement. That means it did not satisfy the inequality. So what we did is we picked a representative. That means all the points up here would be false. So that means where am I going to shade? Am I going to shade up here or am I going to shade where my pen is? I'm going to shade up here. That's where the true ones would be. And if you don't believe me, because I know you don't, you still don't really know me that well. I get it. Trust is earned. Let's pick a point over on that side of the inequality and let's see. So I'm going to pick the point. Let's go -3, 5. I'm going to pick this point right here. I'm trying to make it nice and dark. I'm going to pick -3, 5. If you had picked that as your test point, well, let's see what happens. I'd have -5 times -3 plus 2 times 5. And I want to know, is that greater than 4? Well, -5 times -3 is 15. 2 times 5 is 10. Is 15 plus 10, is that greater than 4? That's true, right? So if you had picked the test point up there to begin with, you would have got true. That would have told you shade up there. Woohoo! But I picked my test point down below. I got false. And what that tells me is shade the other side of the boundary. Here is yours that I would like you to do, your first one. I'm going to have time for a couple. So your first one, I would like you to do this for me. Please graph this inequality. 2x minus 3y is greater than 6. First, graph your boundary, then solid or dotted, and then pick a test point to determine where you're going to shade. All right, I'm going to get started because I see there's a whole bunch of you that are finished. So if you're still working, keep working. Okay. Everybody works at a different pace. There's nothing wrong with you either way. So first thing I'm going to do is I'm going to graph the boundary line using the equation. So I'm going to solve this for y so I can find the slope and the y-intercept. If you graphed using the x and the y-intercept, if you graphed by plugging in points, all that's great. You can apply whatever method you'd like to. I'm going to divide by the -3, and I get y is equal to -2 divided by -3. Negative divided by negative is positive 2/3 x. 6 divided by -3, a positive divided by a negative is -2. And so what I get now is that my slope is 2/3 and my y-intercept is 0, -2. Hopefully that looks super familiar to you. We've done that for a couple days now. So here's my y-intercept. My slope is 2/3, so that's 2 in the y, 3 in the x, climbing the steps, 2 in the y, 3 in the x. I'm having such a good time, 2 in the y, 3 in the x. There we go. Step 2. This is the new part. Am I going to connect those dots with a dotted or a solid line? Why am I going to use a dotted line? For what reason? There's no equal to, it's just strictly greater than. So I'm going to use a dotted line here. Okay, fantastic. So here we go. There's my straight edge. And I'm going to dot, dot, dot. So dot, dot, dot. Oh, that's so lovely. Great line. Now I have to shade. You can pick any test point you want that's not on that line. Somebody tell me what test point you used. Oh, you guys just love me. I get it. 0, 0. That is the best point to use because, in my opinion, because it makes the arithmetic easier and we like easy. So that means I have 2 times 0 minus 3 times 0 is greater than 6. 2 times 0, 0, 3 times 0, 0. So I got 0 greater than 6. Is that a true statement or a false statement? Again, that's false. So let's notice where our test point is. Our test point is above the line. So if you had just gone into this and said, oh, greater than means above, you're going to be wrong. Okay, so I'm just showing you that. Don't make that assumption. Take the second or two to do the test. So my test point is where my pen is. It's above the line. I got a false statement. So where am I going to shade? I'm going to shade below it. Yes. So down here. So here's my lovely coloring. I'm such a good colorer. There we go. Again, you might be saying, what does that mean? That means that I can pick any point down here I've shaded and it will satisfy the inequality. Okay, that's why we shade. There's an infinite number of answers on the plane. Now, half the plane is answers to this inequality. Here's the next one I'd like you to do. Yeah.
When you're picking the test and everything, if you choose 0 every time, can you just assume that the number that's greater than is going to be the answer?
No, don't make any assumptions. Plug it in, because if it's a less than, we would have had a different conclusion here. Okay, if I had made the problem 2x minus 3y is less than 6, then at the end, I would have had a true statement. And that, so don't assume. That's why I'm giving you these 3 steps. I'm trying to keep them nice and simple so that you can do the same thing every time and come to the right conclusion. Okay. All right, so here is the next one I would like you to do, please. I would like you to please graph this inequality. X is greater than or equal to 6. This is another problem that allows us to review something else we talked about earlier in this unit. All right, first thing is the boundary line. What's the boundary equation on this one? X equals 6. So we went through this earlier. When I'm missing the y and I just have x equal to a number, what kind of line is that? Yeah, it's a vertical line. Okay, so if you didn't notice that, you can of course do the table for it, but this is going to be a vertical line. Okay, so that's a review of something we talked about before. So my vertical line goes straight up and down. And so I'm going to have a vertical line at the value 6. So I'm going to come over here to the value 6, and there's my vertical line. Now, before I draw anything, is my vertical line going to be a solid vertical line, or is it going to be a dotted vertical line? It's going to be solid. Why is it solid this time? because the equal bar, yep, nice simple reason. So I'm just gonna do a solid vertical line. Now, the nice thing about vertical and horizontal lines is you can pick a test point, it's gonna be great, but shading is a little more intuitive here because which side of the vertical line are my X values gonna be greater than 6? Is greater than 6 to the left of the line or is greater than 6 to the right of the line? Yeah, and the number line shows you, these are the exact same Cartesian planes that are gonna be on the test on Tuesday. So you can see the values right there. So I'm just going to shade to the right, and there's my answer. I got one more problem that we're going to work together. Does anyone have a question, comment, or concern? We doing all right? Please let me know. I love questions. You're not a bother or a burden. Yeah, don't. Why you're asking a question? Just kidding. But not funny. Sorry, I'm not that funny of a guy. What's up? Because this is a greater. And so all of my X value, this is the X axis right here. So all of the X values, so here's 6, here's 7, 8, 9, 10. So the X values are getting bigger when I go on this side. So again, if you want to pick a test point though, let's pick 0, 0, right? 0, 0 right here. And so then my X value is 0. So I plug it in, is 0 greater than or equal to 6. So my test point, is that a true statement or a false statement? That's still false. Right? 0 is not bigger than, if 0 is bigger than 6, then we're going to change wallets because I have $0. So whatever you have is going to be larger. So, all right. So over here, I got a false statement. So that means shade over here. So you can go through the test point if you want, but with a vertical or a horizontal line, it's a quicker decision to make. Okay. All right, great. Here is the last thing we are going to do. The last example, this is called a, there's no new information here, okay? Don't worry, I know I'm writing something else down and now you're like, oh, great, something else. So this is called a compound inequality that we're gonna do. A compound inequality is gonna be given to you like this. Here's, I'm gonna have y is less than or equal to 2x minus 3. Then you're gonna have an and then y is greater than or equal to -5. So we're given two inequalities. All it is it's two problems for the price of one. What you're going to do is you're going to graph both, and then you're going to determine where they overlap. Okay, we're going to do these one at a time together. I'm going to give you 3 minutes. I would like you first, please, just to do the y is less than or equal to 2x minus 3. Don't worry about the other one. I'll give you some time to do that one as well. Just do the y is less than or equal to 2x minus 3. Okay, so this one, the boundary is y equals 2x minus 3. So you can see I gave this one to us in a format to save us a little time. It's already in slope-intercept form. And so my slope is 2, which I'm going to write as 2 over 1 since I need a y and an x. My y-intercept is 0, negative 3. Again, if you wanted to plug in points there, that's totally another great way to do it. Okay, so just because I'm doing this doesn't mean you're wrong. I will on the test have some problems that I do give you an equation and ask for the slope and the y-intercept. So that will be expected. But there will be some graphing problems that I just say graph and you can do whatever you want. So 0, negative 3. And then the slope is 2 over 1. So up 2 over 1, up 2 over 1, up 2, and one more time. Very relaxed. I'm so relaxed right now. There we go. Okay, so now the second thing is I've got to connect the dots. Am I going to use a dotted or a solid line? One more time just to make me happy. Why is it a solid line? Because of the greater or the equal, the less than or equal to. Yes. And then, so here we go. We connect the dots. Great. And so then now I need to know, am I going to shade above it or below it? So to determine that, I'm going to pick a test point. What do you want to use as a test point? Okay, sure. I mean, you don't have to use that. I just like that because it's easier. But again, I just want to assure you, you can use any point that's on either side of the boundary. Okay, there's no limitation there except you can't use a point on the boundary. So when I do that, I plug that in. The y value is 0, is less than or equal to 2 times 0 minus 3. 2 times 0 is 0, negative 3. Think carefully about this. Is 0 less than negative 3? Is that a true statement or a false statement? That is false. 0 is bigger than negative 3. So here's my test point. Once again, I got a false statement. Whenever you get a false statement, that means shade the other side. Now, you don't have multiple color pens like I do, so I would just recommend shading make your shading clear so that when we do something else on top, we're going to shade in a different direction so that we can see accurately where they overlap. Okay, so that is our first line. So now on that same Cartesian plane, okay, this is the only new thing about a compound inequality. On the same Cartesian plane, graph y is greater than or equal to negative 5. We're going to do it right on the same thing. Don't worry about where they overlap. We're going to talk about that together. Okay, so my boundary, see a lot of you must have worked ahead and that's totally awesome. Y equals negative 5. Well, again, there's no x here. What kind of line is y equal to negative 5? This one's horizontal. Great. Again, you can plug in points, horizontal. You can plug in points and you can, if you need to, but if you just remember the difference between those two. So here's my horizontal line. Here's negative 5. Is it going to be a solid or a dotted horizontal line? Okay, there's equal there, so you correctly identified that there is going to be solid. You can pick a test point, but remember our horizontal, our vertical lines are more intuitive. Which way are the y values going to be bigger than negative 5? Is bigger than negative 5 up for my y values or down? Up. So I'm just going to make my shading like this. And then the last thing to do when you do have a compound inequality is you just need to, on the test, you just need to tell me where the solution is. You can either shade it darker or just draw an arrow to the region that it is. The solution to this, the points that satisfy both, that's what it means to be a compound inequality. The points that satisfy both are where we have both shadings. So does out here, does that have both shadings? No, it's just red on mine. Down here, does this have both shadings? No. Here. Yeah, thanks for humoring me. Appreciate it. And then where has both shadings are right in here. So I'm just going to shade in this little this little region right here. These are the points that satisfy both of those inequalities. Those are the solutions to the inequality right there. Yes. You only shade darker, like you want to shade both so that you know where the solutions are, but you only shade darker. The final answer is where I've shaded black right there. That is so if you want to shade it darker, or if you can't, then you just draw an arrow and say it's this region right here that is the solution. Great question. All right.